All right, so I'm going to go ahead and finish up this function as well as and just display the common pitfalls that occur. So first thing, so what we do is that we get the next letter. The next letter is at word of index plus, it's at index plus 1, right? And then I ask, are those two things equal? If so, I'm going to return true. Okay, so I'm going to put pitfall number 1 right over here to come back to it. So I guess that would make it pitfall 2. Okay, and what I'm going to do is that I'm going to run it now. So print, and right, I'm printing this because I'm returning these values as opposed to printing them out. Okay, has double letters, and I'm not going to bother taking input from the user. I'm just going to check it. Hello, right? Hello has double letters. So that will, pitfall number 1 over there is index is equal to index plus 1, forgetting that line if you're iterating over using a while loop, which is what I'm doing. So if you're using a while loop, you got to remember to increment your thing. And I'm just going to totally pretend that was supposed to be pitfall 1, and that wasn't an unintentional mistake on my part. All right, so let's go ahead and run it again. True. Great. All right, let's go with test world. So I should get false back. And instead of false, it's going to give me an error saying that next letter is equal to word, that next letter is out of range. So if I debug this, I'm going to go ahead and print, let me go ahead and print out all the let me go ahead and print out get letter, next letter. Yeah, let me go ahead and print out letter right over here after I get it. And let's see what happens now. W-O-R-L-D. So whenever we get to D, to world, whenever we get to the D in the world, we get an out of range exception when we try to check the next letter, right? What's the next letter after D? There is none. That's why we're getting an out of bounds exception, right? So if we're checking 1 over to the right, then we need to make sure that we actually stop to make sure we don't go out of bounds, right? B-A-N-A-N-A, right? If I tell this A over here to check 1 to the right, if I compare it against its neighbor, we're going to get an error. So what I have to do is stop and go to length of word -1. And this will stop before I get to the last index. So now if I return, do that, I'll get false. W-O-R-L, right? And then I don't bother checking D against the next letter because there is no next letter. Okay. Everybody understand that? Okay, I'm just preventing it from going out of bounds by going 1 less, right? Because I'm checking 1 to the right, so I'm checking 1 less. Okay. The other pitfall over here is that people often write this, especially when you're beginning, right? They accompany any if with an else. And this will be bad because W returns false immediately. And this is because because basically B, let's just read through the code. Okay, B compared to A, okay, we get B, we start at B, that's at index 0, we get index 1. Is B equal to A? It's not, so we hit the else over here, return false, and that's it. We return false, we're done. Because we just simply said, okay, are the letters equal? No, they're not, we're going to return false. So this is a common mistake because basically you're just stopping after the first check. What you want to do is you want to check everything. And only after you get by everything do we want to return false. This is a very common mistake. I see about like a quarter of the class make it every semester every time I teach an intro class. So just be aware of that. So that was the last pitfall. So any questions on this one? If you wanted to try doing it with a for loop, it works kind of like this, right? It would be with for I in range. Normally we do length of word, but because we want to go up to, but we don't want to include the last index, we would go -1 over there and ask, and I'm just going to not bother doing the assignment statement. If word of I equals word of I plus 1, right? If the thing at index I is equal to the thing to the right of it, this is just simply a much more condensed version of it. Return true. And if we get to the end of the program, return false. So those are the two solutions for the first one. If you have an answer that works that's different than this, that's perfectly fine. There's many ways to do this one. Okay, so now let's take a look at the next problem, palindrome detection. So palindromes are fun words. Radar is a palindrome. Race car is a palindrome. Taco cat is a palindrome. Palindromes are really fun. They're the same words that are the same, spelled forwards and backwards. More advanced palindromes end up being things that are spelled the same forward and back if you ignore the spaces and punctuation, such as, so for instance, a man, a plan, a canal, Panama is a palindrome if you ignore all the spaces. Okay. So so a lot of these are, so it's pretty fun to just look for palindromes, but I like Taco Cat. So what I want to do is write a function that detects if a word is a palindrome. Okay, so banana, apple, and aardvark in these cases aren't palindromes, but radar is. Right, radar is a palindrome. Okay, it's the same string reversed. Now there's a couple ways to do this one, and again we're doing a return true or false. So there's a one-line solution, and then there's another solution. The one-line solution involves using what you know about string slices. Okay. The other solution, which is the more traditional solution to figure this out, is you build a new string that is the original string reversed. So how would we do that? Well, we'd iterate over the string backwards. Right? So iterate over the string backwards, and for every letter, add it to the new string. So you take your word, go through it backwards, add each letter to the reversed word that you're building, and then compare the two. If they're the same, congratulations, you have a palindrome. If they're not the same, you don't. So let's start out. I'm going to start you out on that, right? Def. So what we're going to do is that we're going to write, well, first off, I'm going to create a bunch of spaces over here so that this is up at the top of the screen, right? Def is palindrome. I can never remember if it's palindrome or palindrome. I think it's palindrome. Check if the word is a palindrome. So what we're going to do is we're going to create a string called reversed word. Right? Reversed word is equal to an empty string. And what we're going to do is we're going to build that string one thing at a time, one letter at a time. And then at the end, what we're going to do is that we are going to say if word is the same as reversed word, if they're the same, if the word is the same as a reversed word, we're going to return true. Else, we're going to return false, right? For the one-line solution, if you want to try that, palindrome one-liner, if you want to try that, it will look something like this. return word equals, and then you got to figure out what's on the other side using slice notation. It's actually a very short way to do it. Okay. So else, oh, I completely messed up there. Else return false, right? Okay, so over here what you need to do is iterate through, for this one, if you're trying the top solution, iterate through each letter of the word, but going backwards and add it. That way what we'd do is that for banana, we'd go through backwards, so we'd add A to reversed word, then N, then A, then N, then A, then B. And we'd be checking an-ab versus banana, which in an-ab does sound like it's some kind of weird fruit, I guess. So I guess it's got that going for it. All right, so go ahead and try your hand at that one, and I'll be back here in 5 minutes.